Okay, Assalamu alaikum, welcome back. So inshallah in this session I would like to review the MVVM and also give you some more details about the major component that comes with Android Jetpack that allows us to build apps that follow this MVVM architecture. And these components that are part of Android are ViewModel, the live data, and data binding. So I'll be explaining those and showing you some examples as we move forward. So let us start with the MVVM. So MVVM is an architecture. What do I mean by architecture? So architecture is a term that means what are the components. It defines the components of the system and the connectors between them. What are the components that make up the system and how these components interact with each other. So there are many architectures out there when we build software. One of them happens to be MVVM, which is a very popular architecture when it comes to building user interfaces, particularly Android apps, iOS, even web and desktop apps. You can follow this architecture. And what does this architecture says to us? Go ahead and break your application into three major components. The first component is the view. And the second is the view model, and the third component is the model. So break your application into these three components, and each of these three, they have a clear role to play inside your app. So what is the role of the view? So the role of the view is to provide the UI, to allow our users to provide us some input. Also, when there is some data change or some results coming from computations in our app, we take those results and display them on the UI. This is the role of the view, is to provide a user interface either to get some input or to display some results. What about the view model? The view model, we use it to hold data. So any data that we need in our UI should be declared and managed by the view model. And by the way, this view model also notifies our view. You can see here it notifies our view whenever the data that is being displayed on the view changes. If there is any change to this data, the view will be notified. For example, if the view is showing some list of news, whenever this list of news change from a data source, like for example from a web API that we will start seeing from next week, inshallah, whenever this piece of data news changes, the view model notifies the view, so the view can update itself based on the new data that is received. Also, if you need to do any computation or any logic, we should not put it in the view. We should instead move it to the view model. So this is the role of the view model. The role of the view model is to provide data to the view. Also, if there is any changes to this data, the view model should notify the view. Also, the view model should take care of any logic and any computation in our app. The third component in MVVM is the model. And the model, the role of the model is to handle all data operations. So the view model, so the model has, the first thing it has is entities. Entities are nothing but data classes. Data classes. They do not do any computation. They don't have any logic. They just hold data. For example, we might have a user class. It just has user ID, first name, last name, email, phone. That's it. It does not have any logic. It does not have any ability to read and write data from some source. The logic and the methods to read and write data from some kind of data source, it could be from a file, it could be from a database, it could be from a remote web service or web API. We do that logic of reading and writing, we put it in a repository. So repository will be able to read and write either from a local data source such as a database or from a remote web API. And from next session we will see how to get data remotely from a remote web service running on the web. So these are the three components. The view takes care of the UI, the view model provides the data to the view and performs any needed logic and computation, and the model takes care of data operations. That's it. This is how you divide your app. Now, while developing your app, you must keep in mind these key principles. So whenever we talk about architecture, we talk about components, we talk about how these components interact, and we also have an architecture comes with some principles that we should keep in mind and follow and not break as we develop our app. So the first principle is the separation of concerns. Each of these components has clear role and they should not go beyond their role. So the role of the view is to provide a UI. The view should never try to go to the database and read data directly. Who should take care of this? The model. Even the view model should not read data directly. It should call the model, and the model is the one that should do the reading and writing from a data source. So this separation of concern simply means every component should focus on its role and do not go beyond its role. That's the first principle. Second principle is loose coupling. Loose coupling. Loose coupling means the opposite of loose is tight coupling. So we want our component not to have too many unnecessary relationships between them. We don't want them to be linked together. We want them to have only the absolute minimum links between them. For example, in our case, the view model should not have a reference to the view. So the view model should never access the view directly. Of course, the view can access the view model, but not the other way around. The view should never access the model directly. It should not even know that there is something called model in our app. They are completely isolated. The model is unaware of the view. The model does not even know that there is a view. Maybe there is no view. It doesn't care. So that's what it means by loose coupling. And this is very, very important, because if they are not aware of each other, I can go ahead and change the model or go ahead and change the view with minimal impact to the model. If I change the view, it does not affect the model. If I change the model, it might not necessarily change the view. What I mean by changing the model, I might, instead of reading from a file, I read from a database, or I get the data from the web. The view does not really see this. It does not really care. You can switch between data sources and the view does not get affected. Of course, if you change the structure of the entities, if you add a new attribute to the user object, for example, the view might need to change, of course. But if you are changing the inner working of the methods, reading from different data sources, the view will not be affected. So because we leave them not connected, we reduce the impact of change, and this is very important principle. The other principle is that this MVVM heavily uses the observer pattern, which means the view observes the view model. Whenever there is a change in the data that is stored in the view model, the view model notifies the view of the changes, and the view model observes the model. And this is done in Android thanks to this very powerful class called LiveData that I will explain shortly. So the MVVM heavily relies on the observer pattern to keep the view and the view model synchronized, to keep the view synchronized with the view model, and to keep the view model synchronized with the model. And the observer pattern also enables us to achieve this loose coupling. And I will explain this more through an example shortly. The other principle that we will not cover in this course is called the inversion of control. And what this inversion of control means, basically, whenever the app, for example, in the view model, if I need an instance of the model, I don't go and create it myself. I ask some library, typically called dependency injection library, to give me an instance of that object that I need. But this is a little bit advanced topic. Don't worry too much about it. We will not be covered in this course. But these are the principles that we need to keep in mind and need to follow when we are implementing an MVVM-based application. So I hope it's clear. And why are we doing all of this? We're doing all of this for one major goal: make our apps easy to maintain and easy to test. How is this achieved? Through separation of concerns. Because our UI is separate from the app logic, our app is much cleaner, much more flexible, and easier to understand and change. As I explained, I might change the view without touching the model. I might change the model, such as reading from a different data source, without affecting my view. So the change is much easier, and also the testing is much easier because these components are not spaghetti code calling each other and referencing each other. It's much easier to change. They are quite separate and independent. I can build the model, test it separately before I plug it with the view model. And I can test the view model separately before I connect it with the view. And that is the idea of testability. This is very critical for real apps. That's why MVVM is very popular architecture when it comes to mobile apps, either on Android or iOS. So the skills and the concepts you learn in this course are easily transferable to other platforms such as iOS or the web. Now, MVVM is not some theoretical concept. It's something really practical, and Android is doing a good job in providing classes and libraries to help us build MVVM-based apps, particularly the classes that come with this Android Jetpack, which was first released in 2017. So it's quite new. And this Jetpack comes with many very useful classes and libraries that helps us to build MVVM-based apps, particularly the view model, which is used to store UI-related data, and the live data to provide us with observable data items, and data binding to connect object with UI, and room to read and write from a local database. So I'll be explaining each of those separately as we move forward. Except the room library, we will see it maybe in 2 weeks' time when we start reading and writing to a database from our apps. So these are the components that I will be explaining through in the remainder of this session. Now, just to help us follow our app, follow the MVVM architecture in our app, we could organize our code. This is one way of organizing. You can organize it the way you wish, but this is one way of organizing it to reflect the fact that we are following MVVM. First, we might have a subfolder called model, and in here we can put all the entities in our app. What I mean by entities, for example, user, learning package, it could be country, it could be, for example, in your lab, you have seen entities such as account, transaction, transfer, and so on. So these are entities that hold the data. Then we have a subfolder called repository. These are the classes that read and write data from a data source, such as a database. And then we have a view subfolder. In that viewed subfolder, we can either organize this subfolder in terms of features. For example, in the lab, you have one subfolder for money transfer and another subfolder for transactions. Or you could organize it in terms of roles. For example, you might have the adapters in one folder, the UI classes in another folder, and the view model in a third folder. So the main thing is to organize your project in a way that reflects the fact that you are organizing your project following the MVVM architecture. Okay, so now let's start with the first component that comes with Android to help us build this MVVM. The first one is basically called the view model. And what is the role of the view model? The view model is basically a data holder. So if I have any data in my activity, I put it in the view model. And why do we put it in the view model? For two reasons. The first thing, it survives configuration changes. As I showed you last session, if I rotate the phone, if I have any data stored in the activity, that data will be lost when the phone is rotated. Why does it get lost? Because basically Android recreates the activity every time there is a configuration change, such as phone rotation. This view model is also lifecycle aware. It gets created when the activity is created, but if the activity is recreated, destroyed and recreated because of configuration change, the view model does not get destroyed. It stays alive, and it only gets destroyed when the activity is completely destroyed. If it is explicitly, if we call finish in code, or if the user goes ahead and closes the activity, then the view model will then be destroyed. But if it is just a configuration change, the view model will still be there. It will not be destroyed. Okay, so here is the idea. Any data that you have in your activity or any computation that you do in the activity, you basically move it to the view model. And this will give you guarantee that this data will not be lost if the phone rotates. Okay, and also this will help you to do MVVM. As we said, the activity should focus on the UI related things, only display things and get input from users. The data and computation should be in the view model. That's basically the idea. Now, first of all, let me show you how do we create such view model. Very simple class. It's just a class, normal class, that must extend this view model class that comes from, which is part of Android, Jetpack. And here what you do, you can add properties and you can add methods. So properties to hold data and methods to do some computation on this data. For example, here I have team 1 score initialized with 0, and whenever the user clicks, whenever the team scores a new goal, the user will click increment, and that click will be handled by, that click will call this method here, increment team score, and what this will do, it will basically add 1 to the score. That's it. This is basically the idea of the view model. It's a normal class. The only thing different, it implements this view model base class. Now, on the activity, you basically get a reference or get an instance of the view model. How do you get an instance? Don't go and create it yourself. Don't go and say the normal way we create an instance. Don't go and say view model equals main activity view model. Don't do this. Don't create the instance yourself. Instead, ask this view model's utility function to give you an instance of your view model. And this is smart function. What it does is, so the first time you call this one, when the activity is created the first time, a new instance of the view model will be given. It will be created and it will be returned to the activity. Allahu Akbar. Now, in subsequent calls, if the screen is rotated and the activity gets recreated, of course the onCreate event will be triggered, and the onCreate method will be called, and this line will be called again. Now, because the activity is just recreated, we will not create a new instance of the view model. Instead, we will use the view model that was created before the activity was destroyed. And this is very important. This is how the view model manages to preserve the data stored in it. So let me show you this visually, what it means. So I have my view, which is basically my activity. So the activity was created, and when the activity was created, we ask for the view model. The activity gets an instance of the view model, and it can link itself to the view model. Okay. Now the user decides to rotate the phone. What will happen is this activity will be destroyed and then recreated. But the good news is this new activity that gets recreated will be reusing the same view model. So this way, anything we have in our view model, the data we have in our view model will be preserved. So you can see here, the view is destroyed after the screen rotation, but the view model remains. And this is how the view model helps us to solve this problem of data loss due to configuration change. Just put your data inside your view model, and then when you get a reference to the view model, do so by ask the runtime to give you an instance of the view model by using view model by view models, and you give it the type, the data type, the class that you want, and then you will be handed over a reference to the view model. If this is the first time this line is called, you will get a new instance. If it is a recreation, if the activity is recreated, you will get a reference to the previously created view model. So the view model will be preserved upon rotation. If the screen is rotated or there is a configuration change, the view model will survive that change. So you can see here, if I want to show you this concretely, the view model has a much longer life cycle, much longer lifespan. It lives longer than the activity. So here is what I want to say. So here is when the activity is created, the view model will be created as also when the activity is created. Now, the activity, when it's created, it goes through 3 states. So it gets created, started, and then resumed. This is the life cycle. In Android, the life cycle of an activity is it goes through 3 stages: created, started, and resumed. Now, if the user decides to rotate the screen, the Android will pause the activity, stop it, destroy it, then create it, start it, and resume it. And we discussed this last time. The reason why Android does this is because when the screen is rotated, let's say going from portrait to landscape, your activity might be switching to a different layout. You might have one layout for landscape, one layout for portrait. The other thing, if the user, let's say, changes the language of the device, your activity will be destroyed and recreated because it might be using different resources. If your app was English and then the user changes to Arabic, let's say, the activity will be recreated to use Arabic strings and to use, let's say, images or icons that have Arabic text. So that's why Android destroys and recreates the activity. So while the activity is being recreated, the view model survives, it's still in memory. It will only be destroyed if programmatically in our code we call finish inside the activity, which means we are going to destroy the activity completely. Or if the user exits the app or closes the activity explicitly, then at that time the view model will be destroyed and this uncleared event will be raised, and if you have any cleanup to do, you can put it on cleared method inside the view model. So the view model, you can see here the view model, you could have in the view model on cleared and you could do some work in there. For example, you might have some data that you care about, you might store it in a database before the view model is destroyed. So you have the ability to do that if you wish. Okay, so that's basically the idea of the view model. Here are some rules when it comes to the view model. Never access or reference your view from the view model. Remember the separation of concerns and remember the loose coupling. Remember the loose coupling. The view model should not access the view. It should not have any reference to an activity or fragment or views. You should not do this. First of all, is to achieve this separation of concerns. The others is that the view model, remember the view model can live much longer than the activity or the view or the views in the activity. So if you store a variable that references an activity, that activity might be destroyed due to configuration change. And basically you will be referencing an object that no longer exists. And this might lead to memory leak. You are holding on objects that doesn't exist. And also worse, even if you try to access such reference, you might get a null pointer exception and your application might crash because the object you're trying to access is already destroyed. So we need to be very, very careful. Because as I explained here, the activity might be destroyed while the view model still survives. So if I have a reference to this view here, if I have a reference to it, this reference will cause me issues, either memory leaks or it can cause me a null pointer exception. So that's why never reference the view or access the view from the view model. It's the other way around. The view is fine. The view, which is the activity, for example, can access the view model, no problem, but not the other way around. The view model should not have anything to do with the view. It should not access the view directly. Okay, that's the idea. The other advantage, here is another advantage of using the view model. The other advantage is I can use the view model to share data between fragments. Remember, the new fashion of building our apps is that we have one activity and multiple fragments. You already seen previously in the using the navigation component. Of course, you can pass arguments from one fragment to another. You can pass data from one fragment to another. That's one way of doing it. The other way of doing it, you could have shared view model, and one fragment can write, and another fragment can read. And I guess you have already seen this in the lab. If you remember, in the lab, you have if you remember, for money transfer, uh, you had three fragments. The first fragment you select account and you put the amount you want to transfer. Second, you select the beneficiary, and the third fragment you confirm. In the lab 6, what you did, you made these fragments pass data from one fragment to another using arguments that you define on the on your navigation graph. The other way to do it is you have one view model, let's say one view model, and then whenever the user selects the activity, you write it in the view model. And whenever the user selects the beneficiary, you write it in the view model. And finally, confirm will have all the data needed to display the confirmation screen that the user can click to confirm the transfer. So you can share the same view model across multiple fragments. And the way to do that is super simple. All you do, instead of getting a reference, you see here, when we get a reference to the view, we ask the view models, please give me a reference to this view model. Instead, if you want to get a shared reference or a shared view, a reference to a shared view model, you see here this helper function called activity view models. So I'm saying, give me the view model called shared view model, but be careful, this view model will be owned by the activity. So the view model will be owned by the activity, which means it is accessible from any fragment. And this is much nicer to do than rather than passing data between fragments using arguments through the navigation component. So that's another advantage of using the view model. So I hope it's clear. If not, please ask. Now, to use the view model, you need to bring in. Yes, please. Somebody is asking something.
Are we so we need to choose one only, not
Sorry,
both.
can you say it again?
We need to choose only one way, not both. Just like arcs or
Yeah, you won't replicate the efforts. I mean, I mean, args, for me, this is much preferred way of passing data between fragments. It's much better and much cleaner and much simpler to just have one view model class. So a view model class, something similar to this. A view model that has some data and some methods. And basically the data and methods in this class are shared cross fragments. And in any fragment, you can access this view model by simply using you say, give me a fragment. By the way, this should be equal. Say, please give me the view model by using this function, this helper function called activity view models, and you give it the data type of the view model. And that's it. You will get an instance, and that instance will be the same for all fragments. So if one fragment arrived to that view model, those changes that fragment one did are visible to the other fragments. And this significantly simplifies communication between fragments and makes the code much, much simpler without defining arguments and passing data between destinations as the user navigates from one fragment to another. You did this in Lab 6. In Lab 7, you use a better way, which is having a shared view model. I hope this is clear. Okay, so for you to be able to use all these goodies that I explained, you need to bring in a couple of dependencies that are listed in here. So this is from Android documentation. You copy and paste them in your module app build.gradle. You have done this already in the lab. Okay, moving on. What I want to now explain is the next feature, very powerful feature of Android Jetpack. Another important class that comes with Jetpack is live data. Now, so let me make sure you are not confused. The view model, let me just make it clear. The view model is data holder that I use it not to lose my data is if the screen is rotated. The other advantage, the data I put in there in the view model can be shared across multiple fragments. So this is the first piece of library that comes with Android to help me achieve MVVM based app. The second one is a live data. Live data addresses another problem. So if I have some piece of data, such as let's say news, or some variable that may change over time, can be changed over time. So what I do, I take this variable and I wrap it and put it inside a live data object. And then suddenly, this piece of this object that I put inside my live data becomes observable. It start notifying others, especially the view, if there is any change. So if there is any change to this data, it gets automatically pushed to the view. That's the idea. So live data is if I have some piece of data that will be changing over time, I can put it inside the live data, wrap it inside the live data, and suddenly this enables me to watch and to observe this piece of data here. Whenever it's changed, the view will get notified. That's the idea of live data. Now, to bring this idea closer to your mind, this observer pattern closer to your mind, we all familiar with there are people out there in the real world, celebrities, and we have some fans that are following this celebrity. Whenever this famous guy push or put some piece of content, such as an image or a tweet or a post or some update, they put it in their Instagram or in Twitter, and then that change or that post or that update will be pushed to all the listeners or all the subscribers. We call them also observers. So the celebrity acts as an observable that is pushing some updates and some events, and the fans are basically observers. They get notified whenever there is an update coming from the observable. So to be able to achieve this observable or to implement an observable in Android, we basically use this live data class. So let me show you this concretely, what it means. Okay, so I have some team one score. It's likely to change as the app is running. So whenever the user, whenever a team scores a new goal, the user goes and clicks a button on the user interface, and that button basically goes ahead and increments the score whenever there is a new value. So what I can do here, so instead of keeping my score, team 1 score, as a simple int, I put it as a live data int. So I declare it in here. What I'm saying, instead of declaring team 1 score as before, team 1 score, instead of declaring it as an int, if I declare it as an int, it's fine. It is a variable. I can store data in it, but it will not let me know if that variable changed. If I want the team 1 score to inform the view whenever the team 1 score changes, then I have to make it a live data. Now, live data, there is a live data and there is a mutable live data. Live data is a read only. Mutable live data is a read or write live data. Okay, so what I do, typically what the people usually do, inside the view model, I create the variables that I want to be able, the variables that I want to be able to observe them, the variables that I want to be able to observe them, I declare them as a mutable live data. So for example, here I'm declaring team1 score as a mutable live data of type int, and I initialize it with 0. Now, to the outside world, I make this private. And you see here the naming convention, because it is private, I put underscore as as prefix of the variable. To the outside world, outside my view model, I expose this one as a live data, which means people can read the value, they cannot change it. So only inside I can change it. So this is very common pattern people do. They declare the variables as mutable live data, so they can be changed inside. And then they expose them to the outside as simple live data, not mutable. So from outside the view model, we can read the values, but we cannot change those values. Now, inside the view model, whenever the data changes, I cannot just do the normal way, team1 score equal the new value. I can't do this anymore. If there is any change, what I do, I post the value. So instead of doing team1 score equal 5, I will say dot post value, and I give the new value. The reason why I do this, because this will notify the observers. Whoever is observing this team1 will get notified. If I just use equals, they will not be notified. So instead I use post value or set value. I prefer to use post value, just especially as a beginner, so you know the difference. You know here explicitly that the value is being changed and the observers are being notified. Now, how do I observe from the view, from the activity, how do I observe the live data? How do I observe the live data? It's very simple. All I do, I go to my property that is declared as live data, and I attach to it an observer. So I say observe, please observe this piece of data. Whenever it changes, I want you to take the new value and display it on my user interface. So whenever this data changes, either it changes in the background, maybe we go to some web API or some database, and we change this value in the background, for example, the view will be automatically updated. So this is the power of live data. Very simple concept. Any value that is likely to change in the future, and I want the view to be notified and synchronized with the model, what I do, I take that piece of data, that variable, and declare it as a live data object. And then from the view, I can go to that property and observe it. Observe it means I listen to changes. Whenever this value change in this scenario, all I am doing, I am going ahead and changing the user interface. Okay? Now, live data is also very, very powerful and very, very smart because it is a life cycle aware. What do I mean by life cycle aware? Now, here is my activity and here is my view model. And in here, I have some data I am observing. So whenever there is a change, the view model, the live data will basically notify my activity. Now, if the activity is not in the foreground, the activity is not visible on the screen, the live data basically stops updating the UI or informing the UI. There is no need because the activity is already stopped or it is in the background or destroyed. The activity no longer receives updates. So that's what I mean by lifecycle aware. In fact, if the activity is destroyed, the live data will remove the subscription to this activity. This activity will no longer receive updates. And this is very important to not have memory leaks and not to do trying to push data to something that does not exist. So live data not only it is able to inform our view whenever there is a change, but if the view is not on screen, if the view is not the user is not using the user is using another app and the view is in the background, the live data stops informing the view. Once the view comes back to the foreground and gets the focus and the user is using the activity, then the activity will receive the last update. So that's why live data is also life cycle aware. Life cycle aware. What I mean by life cycle aware, if the activity is not in the foreground, or it is stopped, or it is destroyed, that activity will no longer receive updates. All right, so the last concept I will quickly introduce in the remaining few minutes is data binding. So this is another feature. What data binding allows me to do. So instead of, you have seen this, instead of taking data from my objects and writing it to the view, I can do this programmatically, of course. I can read from my object and write to my view. For example, here I have an object called user, and I have this user object has a username property. I read from the object and I write to the username text view text property. I assign the username to the text property. This is one way of doing it. You have seen how to do this. Now, I can get rid of this code by simply going to my view and defining a data binding expression. So what I'm doing here, I put an expression put my curly brace, and put the name of the object dot the property that I want to access. And that's it. What I have is the value of this object will be assigned to the text property of this text view. Not only this, if this happens to be an observable, if the user object is a live data, this value will be automatically updated and the UI will be automatically updated with zero coding whenever the username changes. Very, very powerful. So data binding is all about linking. You can see here and basically linking the UI with my objects. And this is done in the XML layout. And I don't need to do any coding to actually manually and programmatically read from the object and write to the view. I can just declare this binding, do it declaratively, and the value will be the value of username will be assigned, and whenever the value changes, this will be auto updated. So that's what data binding means. And to be able to do this, you need to do a couple of things. First, you need to go to your build.gradle, you apply this plugin, and you basically enable data binding. So you do Android build features data binding true. So you go ahead and enable data binding. The other thing you need to do, you need to go to your layouts. You remember your XML layout that defines the UI, and you need to put it inside the layout tag. So let me show you. Here's my layout, for example, my constraint layout. This is the layout that we have been using all along. What you do, instead of having this constraint layout as the root, I have now layout as the root. And inside the layout, I can declare variables. For example, here I'm declaring a ViewModel variable, and I can access the Team1 score from the ViewModel. So yeah, in the layout, I can declare variables, and then I can access those variables in my data binding expressions. Okay. Now, how do we connect the view model with the view? How do we connect the view model with the view? So we already, so what is really different here? When the view, if you are using a fragment, typically you do this in a fragment. So on a view created method in the fragment, in view created, what you do is you do this. This class will be automatically generated. This class will be automatically generated once you add this. Once you add the layout and add this, you add the layout as a root. Android Studio will automatically generate a class that has the same name as the activity with the suffix binding. So in my case, I have a fragment. I have an activity, a fragment called profile fragment. So this class is auto-generated. So I use it. So I'll say fragment profile binding dot bind view. So the view is one of the parameters of on view created. Remember, you remember every fragment has on view created method, and basically this on view created gives me access to the view. I take the view and call this fragment profile binding dot bind and pass it the view. Also, I'll say view, this class that I create, this object that I create, I go ahead and say lifecycle owner equals this, which is basically the life cycle of this binding will have exactly the same life cycle as the fragment. Then I get the view model. We already know how to get the view model. And then I take what I'm doing here. I'll take the profile from the view model and assign it to view binding.profile. You can see here what I mean here. The variables that you have, the variables that you declare, the variables that you declare in your layout, you need to set them. You need to assign some value to this variable. So that's what you do on view created. On view created, once the view is created, you create an instance of the view binding. You set the life cycle of the view binding to the fragment, and then This code is the same. You just need to reuse it again and again. It's exactly the same code. And then basically you take some data from the view model and assign it to the data that you declared in your view binding. And this is how you basically link some properties that you have in the view model with the properties with the data that you declared in your layout. Okay. I think that's it. Like I think I just want to say one more thing. You can either do one-way binding. One-way binding means whenever the object change, the view will be changed. You can also do more advanced, will not be emphasized in this course. This is just for your information to be aware of it. You can also do two-way binding. Two-way binding, which means if the data changes in the view, it gets reflected on the object and vice versa. But two-way binding is a little bit complicated in the sense that the object that you want to bind with, it must implement this class called base observable. And then you need to provide a get and set. And in the set, whenever the value change, you need to call notify property changed. So that's why, and also you need to annotate this every property with this bindable. So it's a bit too much things to do to get this small benefit of doing two-way binding. So I put it here just for you to be aware of it. You can do it. You can do two-way binding, which means if the UI change, if the view change, you can reflect the change in the object and vice versa. But unfortunately, it's not as elegant so far. Maybe they will have a better ways in future versions. The objects you want to do two-way binding with must implement base observable, and every property, whenever it changes, you need to call this notify property changed. So I find it a little bit too much work for simple added value. So I decided to ignore it. You're not required to really use it in your project or assignments, but just be aware of it, that it is there if you want to use it in more advanced scenarios. I think that's it. There is only one thing left. Unfortunately, I didn't have time to cover, which is binding adapter. I might explain it next time. Okay, thank you very much. So we'll take a small break, and I will be back at 10 past 12 online again. If you have any questions or clarifications regarding your project, I'll be able to answer them.